All right, so converting this to polar, it's a lot more straightforward when you do it this way. So we're going to go from dx dy to dz to dr d theta dz. But remember, you also get that default r when you go to the convert to polar. I'm just going to worry about the bounds. Your integrand is x, which then converts to r cosine theta. But we're not worried about that right now. We're just going to focus on the bounds. So what are the bounds? All right, now you get dr d theta dz. Start with dr. You get, right, convert this equation into, convert it to r. So we all know that x squared plus y squared equals r squared, right? So z equals r squared, right? And remember, this antiderivative is going to be a function of theta and dz. Usually theta is something that we're not concerned about and ends up being a function of dz. So now r equals z. No, square root of z. So that's going to be there. Of course, the bottom bound is 0. Bottom bound is 0 for all of these. So that's easy. We're already given the bounds for z. That stays the same. So we got this. So what is the bound for theta? Well, this was the same situation in a previous problem. Right, this is some kind of parabola. I'm still trying to understand the equation, what it would look like. But my first assumption, again, was, okay, so this is some kind of parabola. Right, it goes like this, right? And then you have your bounds or whatever. X equals 0, y equals 0. So my natural assumption was theta was 0 to pi, right? But it's not. That's not what it is, because I got to be more careful, right? The equation has the bounds x0, y0. So again, nothing goes past x0 and y0, which means everything is happening right here, which means that the upper bound for theta is pi divided by 2. Now, if x, the lower bound, was a negative number, then theta would go from 0 to pi. But because x is 0, it's 0 to pi half. From this point forward, now you have these bounds. Solving the antiderivative, which is going to be r cosine theta times r. That should be a lot more straightforward, and you should get your answer no problem now.